Okay, so some basic trig stuff here. In the lab, hopefully you realize that sine, cosine, and tangent, which my students used to be like, what are these? And I'm like, they're just kind of like pi. Like pi is an irrational number. And the way you get pi is by taking the circumference of a circle. So you measure the distance around, divide by the diameter. And when you do that, you might have inches divide by inches or feet by feet or centimeters by centimeters, and it cancels and gives you a ratio. So pi is just a ratio. It is, you take the circumference divided by diameter, you get pi. All right, sine, cosine, tangent are the same things except for a right triangle. Okay, so sine is the opposite divided by the hypotenuse side. Now, when you do that, so if this is your angle right there, there's your theta. Opposite is what I'm pointing at. This side, adjacent is touching. And so you're dividing two sides. So inches by inches, feet by feet, whatever. This is going to be unitless. It's going to be a ratio. Okay, it's just going to be a number that you get when you divide. Okay, cosine, so SOHCAHTOA, adjacent means touching, so adjacent over the hypotenuse. And your hypotenuse is always your longest side of a triangle, and it's always across from your right angle. So SOHCAHTOA is adjacent over hypotenuse. And then tangent is SOHCAHTOA, so opposite would be this side and adjacent. So opposite over adjacent. Now, the terms opposite and adjacent are kind of based on your perspective, okay? Hypotenuse will never, ever, ever, ever change. But I could change my angle, which is going to change opposite and adjacent. So say I put beta up here, okay? Notice that here for angle beta, opposite is here, adjacent is now touching over here, okay? For, adjacent over hypotenuse, if I'm up here at beta, adjacent would be this guy touching, and then hypotenuse would be over here. So just know it depends on your perspective, okay? But it's an answer. And the reason they're important is because, and the reason we can use them is kind of like again, like pi in a strange way. And there's a lab that's like this, but you have all these similar triangles. This one's not very good, but you have infinite many similar triangles in here. And so like for sine of this angle is the same for all of these similar triangles, right? I mean, like I can do infinite many. And if I take the opposite side divided by this hypotenuse or this little tiny opposite side by that baby hypotenuse, you always get the same ratio. And so that's why trig is so powerful, because you get the same thing. Kind of like, again, with pi, there are infinite many circles in here that have infinite many, we have different circumference and the diameter. But no matter what circumference, if I take the big circumference divided by the big diameter, I still always get pi. And so that's why pi is super important math too. Okay. The other thing that students don't always remember is, or don't even really know, is what is a radian? Okay, because we measure angles in degrees a lot of times in the real world. And again, a degree is, you take a circle and you cut it into, 360 little openings, okay? And then one of those opening is a degree. So if I take 360th, all right, and I cut this around, however open that is 1 degree, okay? But what is a radian, okay? And usually students look at me and like, I have no idea. All right, so if we were in a face-to-face class, what we would do is in groups, we would measure the radius of a circle. So that is 1 radius. And then what I would have students do is bend it around the circumference and mark it off. So like that would be 1 radius. Now, we're not focusing on distance. Yeah, I make a distance of 1 radius, but it's the angle, like how open is that? Okay, and so, and then we would mark that guy off. So I put a little mark there, and then I come over and say, okay, now I have 2 radii around that side. So if I put a tick mark there, that angle, that openness would be 2 radians, okay? And so then I ask my students, okay, so how many radians go around a circle? So if we started here, okay, so there's that. and here's your radius, okay, and they bend it and they're like, okay, there's 1 radian. That angle would be, openness would be 1 radian, and then they, they're kind of like, okay, 2 radians, and then, maybe come over here 3 radians, and then they come over here 4, and then 5, and again, we're just measuring the radius, and then they come over here, and my students are like, well, there's about 6 point, something radians. Okay, maybe, 6.2, 6.1. And then eventually a student will be like, oh my gosh, there are 2 pi radians around a circle. And the answer is yes, okay, because the formula for circumference is, I always remember as clowns get pied in the face. It's just a manipulation of this, but clowns get pied in the face. We have a unit circle, meaning this is a distance of 1 and this is a distance of 1. So that's a distance of 2. So the diameter is 2. I get 2 pi. Okay. So if you see radians, that's what they're talking about. So if you're like, well, Julie, when they give me pi over 10 radians, I have no idea what I'm doing. Well, this is a distance of pi, or an arc of pi, or an angle of pi. This is telling you to cut that, what is equivalent to pi, into 10 pieces. So like, 1, 2, 3, 4, 1, 2, 4. So I know pi over 10 is that, well, if I could write it, pi over 10 is that angle right there. Okay. I can see that. All right. So let's try to talk about some basic stuff in trig to kind of get you going. So the nice thing about the unit circle then, which is a different video, is then all the sines and cosines. So if you know this, all the sines and cosines. So I can go over here and be like, okay, that's about a negative 0.7, positive 0.7. So that's negative square root of 2 over 2, square root of 2 over 2. So I know the cosine of that angle is that. I know the sine of that angle is there. And the angle I'm talking about is this full rotation right there. Okay, and if you're like, well, what angle is that? Well, what is that? 90 plus 45, that's 135. In radians, it would be what? Pi over 4, 2 pi over 4, 3 pi over 4. So I know that the cosine of 135 degrees is this guy right here. And I know the cosine, and I could write in radians, is that. If I want the sine of this or the sine of that, I get right there. Okay, so the unit circle helps you get all of those. Okay, now let's talk about converting that. So right here on your unit circle, we know 180 degrees is equal to 1 pi. And then if we go all the way around, we know that 360 degrees is the same as 2 pi. Okay, so we can use this conversion. All right, so say I give you 20 degrees, and you're like, okay, what is that in radians? Okay, we're going to do dimensional analysis. 180 on bottom, pi on top. Cancel. Let's see, zeros cancel. Divide this by 2, divide that by 2. So what is that? 2 goes in there once, 2 goes in there. What is that? 9, hopefully. So I get pi over 9. Now you don't have to write the word radians, because if you see the pi, it's in radians. Okay. If I want to go backwards, so say I give you, I don't know, 2 pi over 3, and you want to know the degrees, which you should have that memorized from the unit circle or be able to find it pretty quick, but we'll pretend you don't. Again, my relationship is, let's see, pi over 180. Okay, if I accidentally do it like that, do you see how you get pi squared? Like they don't cancel. So this is bad, bad, bad. We don't want to do that. So we want to convert to degrees. So I know I want degrees on top, the pi on bottom. This is better because you see how you cancel and you're going to end up with that. All right, 3 goes in there. What? Divide by 3, you get 1. Divide by 360, I get 120 degrees, which is on the unit circle. So I probably would have done that a little bit different. If I give you, say, 5.6 radians, and I want you to know degrees, again, don't freak out. You know you're in radians, so you know the pi goes on bottom and 180 goes on top because you want to be in degrees. And we can grab a calculator and just do the math. So I'm going to take 5.6 times 180. 5.6 times 180. Enter, and then what? Divide by pi. And I have a shift pi key there. What do I get? 320.9 degrees. And that makes sense because I know, it's about 6-ish radians, to get there. So, that seems to make sense. All right. reference angles. Okay, if you understand the unit circle, you do not need to know reference angles. Okay, some teachers only teach the first quadrant, and then students have to try to figure out the other stuff. If you know the unit circle, you do not need that. So for example, if I am down in this quadrant right here, say we're right here, and we're gonna kind of draw what I call a bow tie. All right, so say this is, I don't know, what's 180 plus 30, that's what, 210. Okay, say it says, okay, find the reference angle for 210. All right, whatever. You rotate 210. Well, you know that's 180 rotation plus what? Another 30 degrees. Okay, whatever angle is in your bow tie, that is your reference angle. So in this case, it's 30. All right, that's your reference angle. Say I have something over, let's go over here. So this is 270. So let's go to, I don't know, we'll do 300, okay? Or let's just do 290. Okay, so what is my reference angle if I'm at 290 degrees? All right, so let's draw our circle. So 270 is here, and then I'm going to go, what, another 20. Okay, so I went, here's 270, and I went another 20. Okay, but again, draw the bow tie. And again, if you've never seen a person wear a bow tie, they look like that. So I've never seen a different shaped bow tie. So make sure it's, or like a butterfly, right? Okay, so I go 290. And so then draw in your bow tie. So there's your right angle. Your reference angle always has to be at 0, 0 because bow ties always look like this. So your angle, your reference angle is right there. So the 20 is not your reference angle. But there's 90 degrees in each quadrant. And so if that's 20, what is that? That has to be 70 degrees in there. That's your reference angle. So whatever angle is in your bow tie right at 0, 0, that is your reference angle. All right, and so because I know the unit circle, I actually, I rarely use reference angles. So if, for example, someone says, oh, you have negative 120 degrees, okay, and maybe they want me to find the cosine of that. Okay, so what I would do is I'd be like, okay, negative 120, I'm going to rotate down, that's what, 90, rotate another 30, I'm right there, okay? And that's on the unit circle, so that's great. What is it? I'm right there, so it looks like I'm back a half and down about 0.9, which is a negative square root of 3 over 2. Okay, so what is my cosine there? The cosine is just spits out that ratio. And the word cosine's gone because that's what the function does. I did what the function said, I'm done. Now, I don't do reference angles. Notice I never even figured out the reference angle. I can. This guy right here is my reference angle. What is it? Well, I did 90, and this was another 30. So 30 and 60, this guy must be a 60-degree angle in there. But again, I don't really care. But, if you need to know it, you can know it. Coterminal is something we do a lot in trig. So if you have, say, a 70-degree angle, you can keep adding 360, add 360, add 360 to keep creating infinite number of angles. If I want negative coterminal angles, I could subtract 360, 360, 360 over and over again to create infinite many angles. Kind of like in the Olympics, right? Like, if I'm a skater, right? Like I could, if I take off, I could spin once, 360, spin again, 720, keep spinning around, correct? Over and over again, or even a jump or a snowboarder or something. Okay. Same thing in radians. If you have pi over 4, you could add 2 pi over and over again to create infinite many coterminal angles. And if you want negative ones, so again, this is pi over 4, so you're starting right here. So you could keep rotating 360, 360, 360, or negative 360, negative 360, and land in the same place. Now, again, if you're subtract, if you want negative. Now, again, with fractions, you're going to need a common denominator. So times 4 times 4. So what you're really going to do is add 8 pi over 4 over and over again. So that would be what? 8 pi over 4. That would be 9 pi over 4 would be a positive one. And then here, times 4 and 4, if I want to keep doing that, that would be minus 8. So 1 minus 8 is a negative 7 pi over 4. So that's kind of some just general trig stuff, and then I'll make another video on kind of mainly how to do most trig problems. All right, hopefully this helps.